Hi, interested student, welcome back. So today we are on Unit 10, right, on sampling distribution in the lesson sampling distribution of a sample proportion. And today, the previous two videos, we did the normal condition for sample proportion, right? The n times p greater or equals to 10, the n times 1 minus p greater or equals to 10. That's the condition for normality to check for sample proportion. And then we did the mean and the standard deviation of a sample proportion. The mean of a sample proportion should be the population mean, right? Population proportion. And the standard deviation has a formula, square root of the p times 1 minus p divided by n. And today we're going to use that to find finding probabilities with sample proportion. And this can only be done if the sample proportion, if the shape is approximately normal. Okay? All right. So let's go. Suppose that 15% of the 1,750 students at a school have experienced extreme levels of stress during the past month. Well, we all have been going through that a little bit, right? A high school newspaper doesn't show this figure, but they are curious what it is. So they decided to ask a simple random sample of 160 students if they have experienced extreme levels of stress during the past month. Subsequently, they find that 10% of the sample replied yes to the question, assuming that the true population proportion is 15% right here, right? The true population proportion is 15%. What is the approximate probability that more than 10% of the sample would report that they experience extreme levels of stress during the past month? So first thing first, we need to figure out if the sampling distribution is normal or not. So we need to look at n times p, and my n. So for example, this is my p 0.15, and my n is 160. N is 160. So if I take 160 times by 0.15, right? 160 times 0.15, and that is 24. Okay, so that is greater or equals to 10, and we need to take 1 n times 1 minus p, which is 160, times it by 1 minus 0.15. And let's see what that gets you. 1 minus 0.15 is 0.85. So we need to take 160 times 0.85. And that is, woohoo! So that gives us 136. Greater or equals to 10. So we now know that the sampling distribution of the sample proportion is approximately normal, right? It's approximately normal. So we now have established that. But we need, since this is a probability problem, we need to use normal CDF, right? Normal CDF. So let's kind of try to understand normal CDF. So here you're trying to find the probability that the sample proportion is greater than 0.10, right? That's what we want to find, right? Let's read the question again. What's the approximate probability that more than 10%, so it's 10% is 0.1, right, of the sample would report? More than 10. So the sample, right? Can you see that this is sample proportion? The symbol p hat is greater than 0.1. We want to find out what's the probability of this particular event happening. And you got to use normal CDF because why? We're dealing with a normal distribution, right? Because we just prove using this, we just prove that the sampling distribution is approximately normal. So we're using normal CDF, and we need four things. We need the upper bound, we need the lower bound here, right? And we need the upper bound, and we need the mean, and we need the standard deviation. Okay, standard deviation. So, if I may, I'm just going to draw this normal curve. Not very well done, but you get the idea. So, if I were to do here as 0, right? Mean is 0, and this is 0.1. So, let's say, right, let's say 0.1 is here. I don't know where 0.1 is. So, let's say 0.1 is here. And they say more than. So, I have to shade more than 0.1. Right? And this is going to positive infinity. So my lower bound, ladies and gentlemen, my lower bound, as you can see, the lowest bound of the area, right, is zero point 0.1. Upper bound is going to infinity. Now we do not have an infinity sign on the calculator, so we put a big, big number. What's the mean? The mean of this problem, remember, mean of this problem is that, maybe I can write it in a different way. What is this? What is this? Isn't this equals to P? Right? The mean of the sampling distribution, right? This is what it means. The mean of the sampling distribution of the sample proportion is equals to the population proportion. And in this case, the population proportion is 0.15, and I can put the 0.15 here. Now, what is the standard deviation? Standard deviation of the sample proportion of the sampling distribution is this, right? Square root of P times 1 minus P divided by N. So we need to substitute those values in. P is what? 0.15. Okay, good. 0.15. 1 minus 0.15 divided by N. Ooh, what's my N? What is my N here? My N is 160, right? The sample size. 160. Now, you can put this in here. It's going to be very messy, right? It's going to be a little bit messy. So I suggest you work this out first and then maybe put it into 3 or 4 decimal places. All right? So um, let's see if we can do this. So let's clear this. 0.15. So second square root, I'm going to take 0.15, all right? That's my P. 0.15 times 1 minus 0.15, okay? And then divide by 160. That's my sample size. So here it's 0.02823. Let's put it in 4 decimal places. Okay, so here is 0.02823. And then put this right here, 0.02823. So 2823. All right, so how do I get to normal CDF? And I probably need to write that down, if not I'll forget. So it's so normal CDF 0.1, 99999, and then 0.15, 0.02823. So how do we do this? Right, so I go to second, hit second, and then go to vars, and then go to normal CDF. That's where you can calculate probabilities involving normal distribution. You press enter, they'll ask you 4 things here. Lower is 0.1, right? And then my upper is 99999, and then the mean is 0.15, isn't it? My mean, my population proportion is 0.15, and then my standard deviation here is 0.02823. All right. So if you're using the app, you should be putting 4 things and then indicated by the comma. You need to put, just like on the calculator, So this is what you should be putting in. You press second bars, you go to normal CDF, you put 0.1 comma 999999 comma 0.15 comma 0.02823. Okay, and then when you press enter, voila, 0.9617, so on and so forth. And here the closest to it is this one, 0.96, right? If you round this to 2 decimal places. Sweet. Okay, I hope this is making sense. Now, a local agricultural cooperative claims that 55% of about 60,000 adults in the county believe that gardening should be part of the school curriculum. Huh. It'd be interesting if we have a gardening class here. However, when you take a simple random sample of 300 of the adults in the county, only 50% say that they believe that gardening should be part of the school curriculum. So, which one is the true population proportion? That's right here, right? And they claim this. So it's 55%. Now, this 50% is it's a sample proportion which they got after doing a simple random sample of 300 adults. So there are a few things we need to write down here. What is my n? My n is 300. The sample size is 300. What is my p? My p is 0.5. Sorry, 0.55 right here. Right, 0.55. So assuming that the agricultural cooperative claim is accurate, what is the approximate probability that less than 50% of the sample would say that they believe that gardening would be part? Now, I want to look at the options. So here you see all the option has probability, which I'm assuming. Now, if there's one option here that says probability cannot be calculated, and that is probably because the normal conditions was not met. But here, apparently, if you look at the four options A, B, C, D, they all have values. So I'm assuming that the normal conditions were met. That will make things a lot quicker. So here, right, they want to find what is 50, what is 0.5. So I don't know where 0.5 is, but I do know where my mean should be. My mean here, according to the question, is 0.55, isn't it? Here, my mean, my population proportion is 0.55. So I should be putting my 0.55 here. That's the mean. That is the mean right here. And 0.55 should be about here, right? 0.5. So, and as the direction indicates, this is less than. So it's going to so this is negative infinity. So guess what? My negative infinity will be my lower bound, and my 0.5 will be my upper bound. So I have to go to normal CDF, right? Normal CDF. And I need four things, right? I need my lower bound, which is negative 9999999. My upper bound, which is 0.5 here. I don't know my mean, right? Actually I do. My population mean is 0.55, population proportion. But what about my standard deviation? How about this one? How about my standard deviation? I need to use this 0.55. So 0.55, right? Remember P times 1 minus P divided by N. Ooh, what's my N? What's my N? What's my 300 is my N. Okay. So 300. So if you put this on your calculator, perhaps I can do 0.55. Okay, so if I clear this, if I press second, this symbol to get the square root sign, so 0.55 times 1 minus 0.55, and then divided by 300. So it's 0.028, okay, 0.02872. Okay, round to the nearest. I can put it 4 decimal places. Okay, so it's 0.0287. Okay, I can put the normal the standard deviation of the sampling distribution of the sample proportion here. So normal CDF, right? Normal CDF. Probably need to write this down. Negative 9999, 0.5, 0.55, the mean, and then 0.0287. So if I go to second vars, calculator here, second vars, and then go to normal CDF number 2. So what's my mean? What's my lower bound is negative 99999. Enter. And my upper bound is 0.5. And my population proportion is 0.55. Oops. Delete. Okay, 0.55. And I need to clear this. My sample, or my standard deviation of the sampling distribution of sample proportion is 0.0287. So it's supposed to be close to 0.04. All right, so hopefully this makes sense. Hope that the video helps. Please work on it and let me know if you have any questions. Thank you very much. All right, see you next time.